All right, so today's lesson is 9-3, which is solve ratio problems. So the first thing I asked you to do is write down those steps to using a bar or tape diagram. Okay, bar tape, that's a synonym. Okay, they're going to use those are the same kind of diagram. So step 1 is to draw a bar. Step 2 is to divide it up and shade and label the diagram. And then step 3 is to find a value of each section. Okay? All right. Example 1. We want to use a bar or tape diagram to solve the ratio problems. It says a survey of randomly selected students found that out of every 10 students, 3 said they get their news from their cell phone. If there are 750 students at Heritage Middle School, how many students can be expected to get their news from their cell phone? So for the first thing we want to do is we want to look at what's important here. So what's our important information? There are 750 students at Heritage Middle School, okay? So there are 750 total students. What else is important here? Right. So out of every 10 students, 3 get their news from their cell phone. Okay? And what are we looking for? Right. How many students get their news from their cell phone? Okay? So step 1 is to draw the bar. Okay? So we need to know how many sections do I want to have in this bar. So what's my first ratio? What's my ratio? Okay? So it says out of every 10 students, 3 get their news from cell phones. So the ratio is 3 to 10. Is everybody clear with that? So that means we want to have 10 boxes in our bar. Okay? So there we have the total 10. See, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 boxes. Okay? Now, 3 out of 10 said they get their news from cell phones. So how many are we going to shade here? 3. Very good. So go ahead and shade the 3. And shade the 3. And that is the 3 that get their news from cell phones. Okay? That's the 3 that gets their news from cell phones. What's the whole thing is total students, right? Now, if it says there are 750 students, if there are 750 students, we got to figure out what number goes in each one of these boxes. So if there are 750 total students, and there are 10 boxes here, how many students go in each box? How do I figure that out? We do 750 divided by 10. Very good. And that's going to give us 75. Is everybody clear? So in each one of those boxes, we have 75, 75, 75, 75, and so forth. Go ahead and write the 75 in all of the boxes. Now, there's my bar diagram. Now I can answer my question. How do I find out how many students get their news from cell phones? Yellow, the highlighted yellow is what we...
Out
You just add up the shaded parts, right? Of course, repeated addition is multiplication, so I can do 75 times 3, and of course, 75 times 3 gives us 225. So 225 students get their news from cell phones. All right, so you're going to take 3 to 4 minutes to work on this one with your table partners. It says a survey of Mrs. Thompson's class shows that 17 out of 30 students have a dog. If there are 300 students in the school, how many students can be expected to have a dog? All right, so the important information is that the class, let's see, shows that 17 out of 30 students have a dog, right? There are a total of 300 students in the school, and we want to know how many students have a dog. So, we have to have 30 boxes, right? How many of those boxes are we going to shade? 17. Very good. So we're going to shade in 17 of these boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17. All the way over here. All right, so 17. This yellow, what does that represent? Right, this is the one how many students have a dog, right? How many is the whole thing? What the whole thing is 300. The total is 300 students, right? Now, how do I find out what number goes in each one of those boxes? 300 divided by 30. Very good. 300 divided by 30. That gives me 10. So that tells me that 10 is in each one of these boxes. Is everybody clear with that? So 10. Those are 10s. So I'm going to write it. You're going to write it. Okay? 10, 10, 10. Now, how do I find out how many have a dog? What am I going to multiply? 10 times 17. So 10 times 17 is equal to 170 students have a dog, right? All right, so example 2 is to use a bar or tape diagram to solve ratio problems again. It says a survey of randomly selected people found that the ratio of people who prefer oatmeal raisin cookies to those who prefer chocolate chip cookies is 3 to 5. Now, notice the previous example was part to total. What's this one? This is part to part. Very good. So there's a difference with these two kind of problems, okay? So it says, oh, we already read it. So now we want to look at the rest of it. It says, if 27 people said that they prefer oatmeal raisin cookies, how many said they prefer chocolate chip? Now we want to draw a bar diagram. So the important information here is that, one, we're comparing what to what? Oatmeal raisin cookies to those who prefer chocolate chip cookies, right? So, oatmeal raisin to chocolate chip. And the ratio is 3 to 5. So which one represents oatmeal raisin? 3. And the chocolate chip? 5. Okay. Also, we know that 27 people said they prefer oatmeal raisin. Okay? We want to find out how many prefer chocolate chip. Is everybody clear? All right. So we're going to start off with drawing a bar or a tape diagram. Okay? So how many sections do I need to have in this bar? The ratio is 3 to 5. So we want to have 5 sections. Very good. So let's split this up. So here we have 5 sections, and we have oatmeal raisin to chocolate chip cookies. Now the ratio is 3 to 5. So we are going to shade in 3 of these. Okay? This represents the oatmeal raisin. This is the oatmeal raisin. I'll say oatmeal O.R. Okay. Oatmeal raisin. And the whole thing, the 5, this represents the chocolate chip. Everybody with me? Now, it says 27 people prefer oatmeal raisin. So, this is oatmeal raisin, and that's 27 people. How do I know how many people go, what number goes in each of those boxes?
So you multiply 3 times.
Okay, because we have a total of 27, and there's 3 boxes, we divide 27 divided by 3, and that gives us the 9 in each box. Is everybody clear? So that's 27. Now, all of the boxes have to have 9 in it. So now you can figure out how many prefer chocolate chip. How do I figure that one out? What operation do I do? Multiplication. So we're going to multiply 9 times the 5 boxes. So that's going to give us 45 prefer chocolate chip. All right, Elise's mom works at a preschool. There are 13 teachers at the preschool. The ratio of the number of teachers to the number of students at the school is 1 to 6. How many students attend the preschool? We want to draw a bar or tape diagram, again, that's the same thing, to support your solution. So I'm going to give you 3 minutes to work on this with your table partners, and then we will start going over it. So there are 13 teachers at the preschool. The ratio of teachers to students is 1 to 6. So we need to have 6 boxes in our tape diagram. Okay? Now, how many of those boxes are we going to shade? 1. And that 1 shaded box represents what? Teachers or students? Teachers. This is teachers. We want to know how many students are at the whole school. Is everybody with me? All right. So this is total students. Now, it says there are 13 teachers at the school. So in this box we have 13. Is everybody clear? So in all the rest of the boxes we have 13. Very good. We have 13 in each of those boxes. So to find the total number of students, we need to take that 13 and multiply times 6. So 13 times 6 equals 78. So there are 78 students at the preschool. We can also use double number lines and equivalent ratios to solve ratio problems. Okay? So, for this example, it says, use double number lines and equivalent ratios to solve ratio problems. The manager of a small hotel determines that it takes 30 loads of laundry to clean towels and sheets at a hotel's rooms each day. A large bottle of laundry detergent contains 150 ounces, and the label indicates that the contents of the bottle can clean 75 loads. We want to know how many ounces of detergent are needed to clean the hotel's towels and sheets each day. So here, you guys, this is the double number line that is created from that diagram, and from that problem. So we want to get to how many ounces for 30 loads, okay? The ratio that we're starting with is 75 to 150. So, can I get from 75 to 30? Not directly, right? Can I get from 75 to 15?
Yes.
Yeah, so 75 divided by 15, we can just divide by 5 to get to 15. Is everybody with me? What's that called when I divide? Scaling back, right? So we're going to divide by 5 here. That gives us 15. We're going to scale back here, divide by 5. That gives me 15. Is everybody clear?
Yeah.
I mean, 150 divided by 5, that gives me, what's 150 divided by 5? 30, right? So now I can go from 15 to 30 by doing what? Scaling up by multiplying times 2. So now I can multiply times 2 down here. So 30 times 2 is 60. So it takes 60 ounces of detergent to do 30 loads of laundry. So the last example here is example C. I accidentally wrote B here, but this is example C. So it says, for every 12 students at Perry Middle School, 5 of them share a locker with another student. There are 456 students that attend Perry Middle School. How many students are expected to share a locker? Now, you can use any of the methods that we used that you like to solve this. You can use your tape diagrams, you can use double number lines, or you can choose the equivalent ratios. Okay? I know which one I would choose. I'm not going to tell you which one I would choose, but I'm going to do all 3. So the first one is we did tape diagrams. So here, when we write down the important information, it says that for every 12 students at Perry Middle School, 5 of them share a locker. Okay? It says there are 456 total students at the middle school, and we want to know how many students are expected to share a locker. Okay? So the first ratio there is for every 12 students at Perry Middle School, 5 share a locker. So we can write that ratio, and it's okay that it's an improper fraction. We can write 12 to 5. Okay? I think we should, I'm gonna edit that. I think I would rather say 5 to 12. Okay? Where this is share a locker, and then for every 12, that would be the total. Okay? So, if we're using a tape diagram, which is the first one that we did, we need to have 12 boxes. So, go ahead and write 12 boxes. All right, so here we have 12 boxes. Okay? Now, how many of those 12 do we need to shade in? Well, it's 5 out of the 12, so we want to shade 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those are the 5 that the students share a locker. Okay, and this whole thing is the total students. All right, so let's go back up and see what other important information we have. We've got 5 share a locker out of 12. We have 456 total students. So out of the total students, there's 456, we need to figure out how many go in each one of those boxes. Well, there's 456 total, there's 12 boxes, so to figure out how many go in each box, we just divide by 12. So we've got 456 divided by 12, and that gives us 38. So in each box, we have 38. Okay, and I'm going to go ahead and write it in all of them. All right, and so here, 456 divided by 12, that gives me 38. And now, that's how many is in each box. And now we want to know what this is equal to. How many share the locker? So we've got 38, and we've got 1, 2, 3, 4, 5 boxes. So that's 38 times 5. 38 times 5, which is 190 students. So 190 students share a locker. Okay, so that's the tape diagram. So the second way that we can solve this is using the double number line. Okay, so again, we are comparing students who share a locker to the total number of students. Okay, and we want to go out to 456. I think that double number line would be gigantic. Okay, this, if I use a double number line, you would have to have out to 38 tick marks to get all the way to 456 students. So that would be a gigantic number line, double number line. So that is the reason why I would not choose to do that one. So if you choose to do that one, you go ahead and do it. I'll show you it later. Okay. So the third way that we learned how to do this is using equivalent ratios. So I'm going to do that one. So the ratio was 5 students. So we're doing students with lockers to total students. That's what we're comparing. Locker students to total students. Okay? So the ratio was 5 to 12. And the total number of students was 456. So that goes in the denominator, 456. Now, we know, because of the work that we showed up here, to get from 12 to 456, we multiplied times 38. So that means that we want to multiply 5 times 38 to get this question mark. Okay? So we'll just double check. 12 times 38 equals 456. Yep, that checks. And then 5 times 38, that's equal to 190, which is what we said. So that question mark, I'll call that X. X is equal to 190 students who share a locker. Okay, make sure you have this written in your notes. All right, so now you have the benefit of your lecture and notes so you can show your work using doing your homework for the IXL, which is YMD, which is use trig diagrams to solve ratio word problems. All right.